going to talk to us about the building blocks of blockchain. This is a subject which will work as the founding stone of the FDP. Let me introduce you about the Dr. Raghu Vamsi. Dr. P. Raghu Vamsi is currently working as Assistant Professor, Senior Grade in the Department of Computer Science and Engineering, JIIT Noida. He received BE in CSE from University of Madras, Chennai in 2003, MTech from Calicut University, Warangal in 2007, MBA in Human Resource Management from IGNOU, New Delhi in 2010, and MA in Astrology from PSR Telugu University, Hyderabad in 2014, and PhD in CSE from JIIT Noida in 2016. He has more than 15 years of teaching experience in various engineering institutions and 4 years of research experience. So far, he guided 30 BTech projects, 12 MTech dissertations. Currently, he is supervising 2 PhD scholars. His research works have been published in various reputed industry journals and peer-reviewed conferences. So far, he has more than 30 research publications. His research interests include security in wireless ad hoc networks, security in wireless sensor networks, communication protocols, distributed computing, computer network security, trust-aware security methods, blockchain, anomaly detection, Internet of Things, and next-generation wireless communication. I welcome you, sir.
Good morning, everyone. So, as part of this FTP, since most of the participants here are the faculty members of institutions, and 2-3 registrations are there, which are from the industry, and around 17 participants are there who are with the research scholar as the designation. So, most of the people or participants here are the faculty members. So hence, these faculty members are belong to engineering colleges and universities. So I think by this time in all the universities and autonomous institutions, this concept of blockchain have been introduced as a course to the undergraduate level as well as the postgraduate level. So that is the reason, first of all, let we'll see the AICT model curriculum of courses at UG level in emerging areas. Actually, this was developed by the Curriculum Development Center. So they have developed this. In this, the syllabus was framed like this. The prerequisite for this course is cryptography techniques, data structures and algorithms, in introduction to programming, because this blockchain totally depends upon the cryptography techniques and the data structure and algorithms. And because these are the prerequisites, let we'll see when we are discussing the building blocks of blockchain, these 3 concepts will come into the picture. So here, the learning outcomes will be like this, and detailed content. So they have given the first introduction to the blockchain and other building blocks of blockchain, such as basic crypto primitives, cryptographic hash function, properties of hash function, hash pointer. And before this, what actually the blockchain is and how the blockchain can be used in various applications, whether blockchain itself is a cryptocurrency or is different from the cryptocurrency, and what kind of categories or what categories are available in the blockchain, like such as public blockchain, private blockchain, and these kind of things. And then they have gone for the permission model of the blockchain, permissionless blockchains, and other security aspects of the blockchain. Then they moved on to the how to construct the blockchain. For that, what are the primitives, such as cryptographic hash function, properties of hash function such as Merkle tree, digital signature, public key cryptography, other things. Then they have moved on to the syllabus of Bitcoin and blockchain. Then in which the Bitcoin protocols, like the Bitcoin network, transactions in Bitcoin, Bitcoin mining, and how the block will be propagated, how the mining process will happen, how the mining, what are the economics of the mining. So these kind of things were introduced. Next, the main important thing in any public blockchains is working with consensus in Bitcoin. So this kind of working with consensus in Bitcoin means usually the public blockchains will be having this consensus process, which is a very tough process and a tedious process, in which they have taken the example of Bitcoin, and what kind of consensus process happening in the Bitcoin was explained here. That is what the proof of work is, the one which is said to be the main consensus process used in the Bitcoin uh, Bitcoin blockchain. So they have introduced this, and what are the possible attacks on the proof of work consensus protocol, and what is the monopoly problem, and what are the alternatives to overcome the problem of the proof of work consensus, such as proof of stake, proof of burn, proof of elapsed time, which are somewhat uh, what you call somewhat not that much rigid as the proof of work, but however which can be managed in a easy way. These kind of things were explained. Then the life of Bitcoin miner, mining difficulty, mining pool. So these are the things were presented in the first part of the course. Next part, understanding the blockchain for enterprise, in which how the permissioned blockchain will work. See here, permissioned blockchain is also called as private blockchain. How this permission blockchain will work? What are the use cases of the permissioned blockchain? How to design? What are the design issues for the private blockchains? How to execute the contracts, and how to design the contracts, and what are the consensus protocols used for the blockchain, private blockchains such as Paxos, Raft, Byzantine fault tolerant systems. So these kind of things have been presented in the third part of the course. Next one is a further this is like enterprise applications of blockchain. Okay, and some of the use cases has been presented. Then they have given the fourth concept as the blockchain application development with respect to the Hyperledger fabric. So Hyperledger is a open source project started under the Linux, which is called Linux Hyperledger. Then afterwards, some forks have been developed, in which the Hyperledger, IBM Hyperledger is one, in which various other forks are there, Hyperledger Fabric and many other things. So they have taken the example of Hyperledger Fabric, which is also an open source platform for developing the blockchain applications without cryptocurrency. So here only smart contracts you can develop, and you can build an web application to connect with those to those some smart contracts. So here they have given the description of architecture of the Hyperledger Fabric, policies, membership access control, channels, transaction validation, which are the building blocks of the Hyperledger Fabric applications. So in this FDP, we'll try to cover almost all these things, mostly not Hyperledger Fabric. In this place, we focus mainly on the Ethereum Ethereum blockchain application development. That is a decentralized application development with Ethereum as the backbone blockchain. So in this, we are going to see the concept of the Ethereum and the programming language used for the building the smart contracts in Ethereum called Solidity. Then also we are going to look after the basics. That is what I'm going to cover now is the building blocks of blockchain. I will try to cover some of the main aspects of these topics. Next, we are going to see the NFTs. NFTs in the next session by Dr. Vikas hassija sir. Then tomorrow we are going to see the consensus protocols. This particular thing, working with consensus in Bitcoin by Himanshu Agarwal sir. Then the applications of some of the use cases that are there in the blockchain will be discussed by another speaker. Like that, on the third day, we'll move on to since we are going to get the idea of what is blockchain, what is the building blocks, what is consensus, and what are the use cases, etc. So by knowing, I think by this, within these 2 days, we are going to get this particular idea, so that we can move on to the programming part. So the third day totally deals with the programming, where we are going to mainly focus on the Ethereum and the Solidity programming. That is Solidity smart contract development. Then on the fourth day, we are moving on to the how to deploy these particular web applications or decentralized applications that is built on the blockchain. Then we'll move on to the other topics on the blockchain, such as how the blockchain will help in the in Internet of Things, how the blockchain can help in providing security in cyberspace, and also how the blockchain will be helpful in the medical system, and also what are the blockchain databases, what are the research areas in the blockchain databases, and and its related things. So this is the way how the FDP was planned. And since the case studies were also discussed by the several speakers and application areas, and since some programming is going to be discussed, so I hope this FDP in this way will help the both the faculty members as well as the research scholars for continuing their academics and development or research in their future. I hope by this time you come to know the basic structure of this FTP and what are the topics going to be covered in this FTP. So we'll move on to the basic building blocks of the blockchain. We all come to know that whenever anyone asks you what is blockchain, immediately they will come to know, or they will simply discuss blockchain means Bitcoin. So this is a general idea came into the picture whenever any discussion is happening. So blockchain and Bitcoin are one and the same, are different. We'll see now with some having by throwing some light on the introduction of this blockchain. So a blockchain is a peer-to-peer network to transfer digital assets. In this blockchain, we don't have any central authority, and the entire network is completely decentralized. The participants in this particular network will communicate with one another via peer-to-peer fashion. Originally, this concept of blockchain has been obtained and used especially in the first cryptocurrency called Bitcoin. This Bitcoin is a continuous digital currency system, autonomous and also an autonomous decentralized system. So that is the reason Bitcoin blockchain is considered as the mother of all blockchains. Whatever the blockchains developed so far are inspired and developed, or maybe modified, or further refined with the inspiration of the Bitcoin blockchain. So that is the reason we will call it as the Bitcoin blockchain is called as the mother of all blockchains. Blockchain concepts have been received significant attention thereafter. Thereafter means here, once the Bitcoin came into the limelight, and now being used in many areas such as government, finance, healthcare, supply chain, manufacturing, digital media transfer, decentralized business logic, and distributed resources, crowdfunding, and many others. So now we'll focus on what is Bitcoin and what is blockchain. Here, Bitcoin itself is not blockchain. However, Bitcoin is an application that built on the blockchain. For example, if you consider email, in order to send an email to your friend, you need to have an internet connectivity. So unless until there is no email and unless until there is no internet connectivity, there is no possibility of sending email from one place to other. In the same way, Bitcoin is an application that require blockchain to work. So with this, you might have got a clear distinction that what is blockchain and what is Bitcoin. So Bitcoin is the backbone of the application. That application may be a cryptocurrency application, that may be a decentralized application, that may be any other web application or mobile application with where some transactions will happen. So I hope by this time you got an idea what is meant by Bitcoin and what is meant by blockchain. So in this, Bitcoin is a cryptocurrency application. So that is making use of the blockchain. The reason is this cryptocurrency application consisting of transactions, such as a user may send some X amount to Y. So Y may also send some Z amount to some other person. So here these transactions are happening. So that is the reason these transactions will be securely recorded and stored in an immutable ledger on the blockchain. So any transaction at the application level can be recorded and stored in a secured way in the blockchain. So for that purpose, we are going to make use of this particular backbone, which is called as blockchain. So we come to know now the general introduction that blockchain can be used anywhere where there exists transactions to be recorded in a secured way, in an immutable way. Okay, in that particular situation, we can use blockchain as the backbone. So so the Bitcoin is different and blockchain is different. Once by the time of ending of this particular lecture, I will give you the where to use the blockchain and what type of blockchain to be used based upon the project requirements, and a flow graph I will present so that you will come to know clearly where what type of which category of blockchain can be used. I hope by this time you got a basic overview of this. In 2008, Bitcoin proposed by Satoshi Nakamoto. So we don't know who is this person, but whether he is single person or maybe group of persons, we don't know. Satoshi Nakamoto has released a white paper in 2008. This is peer-to-peer electronic cash system, which is said to be Bitcoin. This paper is available over the internet also. The one who want to go through this may go through this particular peer-to-peer electronic cash system. So this is the white paper released by the Satoshi Nakamoto in 2008. So this is what the paper and how this particular Bitcoin uses the blockchain and what are the different uh, things in this, like a consensus protocol, like proof of work, and what are the network used by this, and incentives to the miners, and how the disk space can be reclaimed, how the space can be reclaimed, and payment verification process, combining and splitting of the transactions, privacy mechanism in this Bitcoin, calculations. All these things were clearly mentioned in this particular white paper. So hence you can also go through this. The paper name is Peer-to-Peer Electronic Cash System by Satoshi Nakamoto. Bitcoin enables peer-to-peer transfer of currency without central authority. How the Bitcoin enables the, if there is no central authority, how this particular Bitcoin enables the trust and security, because you have a bank account and some other person may also be having a bank account. Whenever an internet transaction is happening, you may send some amount to your friend so that the banking servers will take care of the security of transferring the exact amount to your friend. Here you can trust the bank and the security will be maintained by the bank. So here bank will become the central authority. But the Bitcoin is a peer-to-peer and a decentralized system in which how this particular trust and security can be maintained. This is what the main question. This question can be addressed with the help of introducing the blockchain. So that is the reason blockchain is called as the backbone for the cryptocurrency or any decentralized application where transactions are involved and where to maintain the trust and security. It is achieved via verification, validation, consensus, and immutable recording of the transactions with the blockchain infrastructure. So here just now I discussed the centralized authority like bank. So you may make the credit card or debit card transaction. So the customer debit card transaction will be sent to bank, and the bank will verify that particular credit card account or debit card number, or maybe it received by some agencies like Mastercard or Visa or RuPay. Then it will send to the merchant's bank, then merchant's account. So these are the transaction. This is the flow of transaction from one place to other place whenever you go for the internet banking. But you look at here how many parties are involved in this. You are the one party, and the bank is another party, and the debit card or credit card provider are some agencies like Visa or Mastercard or RuPay are one part. Then merchant's bank, you may send to some other different bank. So that is another party, and merchant. So here, look at so many parties are involved in this transaction. So these particular parties should be trustable and also should have some privacy mechanism to have this particular transaction secure. Whenever the centralized part is taken out, like banking, etc., banking servers were taken out. So this particular thing was maintained especially with the help of peer-to-peer way in the case of the blockchain, when the blockchain is introduced. So even though any number of intermediaries are available, so they can achieve the trust and security in this transaction via verification, validation of the transaction, achieving the consensus over the transaction, and immutable recording. That means once the transaction is recorded, it cannot be changed in future. So this is what is called immutable recording. In these 4 ways, this trust and security will be achieved in the blockchain infrastructure. Later, we'll see how this can be achieved. Before moving on to this, first of all, we'll understand some terminologies used in the business environment. First, we'll try to understand the business environment and terminologies used in the business environment. And these terminologies will be used throughout the blockchain courses and blockchain literature. So any business is a network. So because you consider any business, maybe a grocery store or maybe a supermarket or maybe any other thing, it can be considered as a network. The reason is it involves financial institutions, it involves supplier, receiver, a manufacturer, and the final end product will be taken by the consumer. So this entire is network. So any business can be considered as a network. It involves customers, manufacturers, bank, financial institutions, partners, stakeholders, etc. Mostly business happen through markets. So that market may be, sometimes the market may be private, like supply chain finances, financial bonds. These are kind of private markets. Maybe sometimes public markets. Public markets may be like a grain market, fruit market, car showroom. Wealth to business is generated via exchange of assets. So obviously, whenever you go to a grocery store, if you purchase some product, you will pay some amount for related to that product, and you will take that particular product, or you will purchase the product. So obviously, this wealth to the business is generated via exchange of assets. Here, this asset may be goods or services. You may take the service like from the service provider, like nowadays many advertisements are coming that they will provide the AC repairing service or cleaning service or maybe other service. So you take the services and you pay the amount, or you may purchase the goods. Goods are also a kind of assets. So wealth to business is generated via exchange of assets, goods and services, except across business contract or transaction. So here, please remember here business contracts. So you will go for paying of amount to the product that you purchase. For example, you have purchased 1 kg of sugar. Then 1 kg of sugar means there is a quantity that is going to be fixed, and you will say that okay, I'm going to purchase 1 kg of sugar. So for 1 kg, this is the thing, and I want to purchase 100 kgs of sugar. What could be the price you will offer? So here the business person may give us some discount on purchasing of 100 kgs of sugar, because 100 kgs is a huge amount, and they will go for the looking of the profit and loss and then go for deciding on how much you are supposed to pay. So that is what the thing called contract. That is what the thing called contract. Or else you may take the service from a builder and you may provide the amount and you may give the plan of the house to be constructed, and some contract, the agreement will be made between you and the builder. And if you might have built up to the first floor, we'll pay this much amount. If you might have built up to the second floor, we may release this much amount. This kind of agreement you may made. So this is what thing called contract. So these business contracts are very, very important in any businesses, and any business will be run to gain the wealth, and this business will gain the wealth with the help of with the exchange of assets, that is goods or services. So whatever the monetary transactions, or whatever the money transactions will happen, these are kind of a transaction is going to be called as transaction in the business. So by this time you come to know the business is a network which consisting of various stakeholders, and mostly the business will happen through public and private markets, and wealth to the business is generated via assets, that is exchange of assets. And these assets sometimes may be tangible and sometimes intangible. For example, assets like a house, car, etc. are tangible, and sometimes the mortgage, bonds, patents, copyright, these are the intangible things. In addition, cash is also an asset with anonymity property. So here cash is one that that may be printed or maybe having some maybe printed or maybe manufactured in terms of coins or maybe any other thing. So this cash is also an asset with anonymity property. And one more thing in the business environment is movement of assets across various entities in a business network are recorded into a ledger. That means a supermarket business may record the ledger like this: how much goods have been came to the store today, and how many products were sold today, and from whom you have got the lot of products, and how to whom you have purchased, to whom you have sold out, and from where you have taken the finance, and how much how much repayment was made. These are all the things will be maintained in a book called ledger book. So movement of assets across various entities in a business network are recorded to a ledger. So a business may have multiple ledgers. An asset transfer onto or off the ledger is said to be transaction. So that means this many products have been received from so and so service provider or so and so manufacturer. So this means here this particular product means this product is the asset. So an asset transferred on or off to the ledger is said to be the transaction. That means in a ledger, I have made a note of that 100 kgs of or 100 bags of rice have been received into the store from so and so rice mill. So obviously it is a transaction. We are going to record on that. If the transaction is happened via condition, then it is said to be contract. So you please provide this particular products or this many rice bags within a certain time. This is a condition here. This is a certain condition. So which is called as contract. So in this thing, first of all, one must remember that these are the key terms which are mainly used in the business in this particular business environment. Also, the same thing you can also realize in the development of the blockchain application. So first one is business is a network which consisting of many entities, like many parties may be involved in this, and this business may be private or public, and wealth to the business will be generated via assets, and these assets may be tangible or intangible, and any movement of asset will be recorded onto the ledger, and the uh, uh, business will happen via transactions, and if the transaction happen via condition, then it's said to be a contract. So I hope by this time you come to know the keywords that are going to be used for the rest of the discussion. We'll see one example, and we'll come to know the difficulty if there is no decentralized server available. if there is a if there is no centralized server, if everything is happening in decentralized way, obviously the trust and security to be maintained to be maintained. Let will see the same business environment and will map to one simple example and will come to know how to safeguard the assets and transactions, uh, and what is the difficulties, what are the difficulties in general, why we require to go for blockchain whenever you develop any decentralized application. Here there are two entities, Ramu and Gopal. Now Ramu is going to provide rupees 1,000 to Gopal. So Ramu and Gopal are two business people. So they used to exchange the goods, and they used to provide some. They used to exchange the financial transactions, and they used to exchange the goods. So in this process, Ramu has provided rupees 1,000 to Gopal. Now, as a business person, just now we have seen a ledger has to be maintained, so that in that ledger, Ramu has to record the transaction that I have given rupees 1,000 to Gopal. In the same way, Gopal is also a business person, so he should also maintain a ledger that I have received rupees 1,000 from Ramu. So this is the way the ledger need to be maintained. So look at here, this is a genuine ledger, how the Ramu's ledger will look like. To Gopal, rupees 1,000. So along with this one, they may also write, okay, on which day they have, Ramu has given rupees 1,000 to Gopal. So for example, today is 25th July 2022 at 10 a.m. I have provided rupees 1,000 to Gopal. The same way, Gopal has to receive, write in his ledger like this: on 25th July 2022 at 10:01 a.m. I have received rupees 1,000 from Ram. So this is the way. This is the way in general a genuine ledger entry will look like. Okay, but if Ramu has not entered this particular ledger properly, improperly or properly, so he might have given an entry like this: to Gopal rupees 1,500. That is, on so and so date and so time, Ramu has provided rupees 1,500 to Gopal. So Gopal is also very clever. He made an entry like this: from Ramu, I have received only 500. So this is a wrong entry which is made into the ledger. If an auditor at the end of the financial session or financial year, if an auditor want to verify it, so the auditor for the Ramu, whoever the auditor for the Ramu, will pick up this particular ledger and simply will go through the number of how much amount was sent and how much amount was received, and whether the balance sheet is tallied or not. This is the only thing he will go for. But actually, he cannot verify whether Ramu has actually given 1,500 to Gopal or not. For that, this particular auditor has to go through the Gopal's ledger and has to verify whether Gopal has received the same amount from the Ramu or not. But the auditor will be different for Ramu and Gopal sometimes. So obviously the auditor cannot merge the ledgers and cannot go for verification. In this way, frauds may happen. So this is the way the corruption, or we can say the fraud kind of thing, will happen in the ledgers. So these particular things are happening in the ledgers because these ledgers are independent to business entities. So for the Ramu business, this ledger is independent, and for Gopal, this is the independent. So there is no dependency between these ledgers, and those are individual, they are isolated. So that is the reason auditor cannot verify by merging all those ledgers. So thereby chance of happening fraud may occur. So that is the reason we need to have a mechanism. We need to have a mechanism to verify in a decentralized way. But for example, if Ramu and Gopal is linked to a central server like bank or maybe some central database, obviously auditor can verify the central database and can easily say that whether the Ramu has sent to Gopal rupees 1500 or not, or whether actually Gopal has received rupees 500 from the Ramu or not. Because in the central server, all these transactions will be recorded. But whenever an individual entity was there, and when the individual entities are working in a decentralized way or peer-to-peer way, it is these kind of things are not possible. These are not possible. So that is the reason the blockchain is one which will help us to achieve the security. By this time, you come to know the scenario that a auditor cannot verify by combining the ledgers of individuals. So that is the reason we require a security and trust mechanism to verify whether the transaction has been done or not, and there is no fraud occurs. So now the transaction was like this: Ramu to Gopal, rupees 1000. So as I told you, you may also add some timestamp before this, so that the timestamp, that is the date on which he is sending and time and the amount. So this particular transaction, whenever the blockchain was introduced, how this particular verification can be done? Whether Ramu really hold this much amount, 1000 rupees. Because whenever you go to ATM and withdraw the amount, if the amount is more than the amount of your balance amount, so obviously it will deny you to give the money. In the same way, whether Ramu is actually having 1000 rupees or not, if you won't have 1000 rupees, how he can send to the Gopal? So that also to be verified, because this is not the physical cash, this is a digital asset. In a digital asset, anything can happen. So for example, if you might have developed, if you might have written some lesson or essay on paper, so you may take a photostat and get the another copy. That too, you can easily verify by looking at first copy and second copy, that one is handwritten and another is photostat. But in case of digital assets, it is not possible. If you might have typed the same essay or same paper or lesson in the MS Word, so obviously anyone can take the copies of that. So you cannot simply say that. You cannot simply say that this is original and this is duplicate. It's very difficult to say. So that is the reason this particular transaction is a digital transaction, and the amount over here is the digital money. So we cannot verify whether this particular rupees, exactly the 1000 rupees, is available with Ramu or not. So for this, in the blockchain environment, what will happen is this transaction will be sent to there are sent to some other business entities or business stakeholders, such as Krishna, Paras, and Radha. So these are the other parties in the business network. So the same transaction will be sent to Krishna, Radha, and Paras. Now the task of Krishna, Paras, and Radha is to verify whether Ramu is already having rupees 1000 or not. That means whether he is having the balance in his account with more than rupees 1000 or not, and whether Ramu has exactly sent the Gopal rupees 1000 or not, to be verified by the Krishna, Paras, and Radha. Before moving through that, whether this Ramu is in exactly that Ramu only, that means whether this Ramu to Gopal, this Ramu is this person or not, whether he is actually sending or not, to be verified, and whether the Gopal address is the exact address or not, to be verified. Then the amount that he is going to be transferred need to be verified, and also they need to keep track of the timestamp that I just now mentioned. That means how many verifications they have to do. The Krishna has to do the verification whether the Ramu is the exact person, is the person exactly, and whether the Gopal address is correct or not, and the amount what he is transferring is correct or not, and also whether the amount transferring is less than the balance amount of Ramu or not. All these things must be verified by the Krishna, Paras, and Radha, who are the other stakeholders in the same business environment. And thereby, Krishna, Paras, and Radha has to reach to an agreement that this particular transaction is correct or incorrect. If these three come to an agreement that these three come to an agreement that whether this transaction is correct, then it must be saved onto the ledger. So this particular process of coming to the agreement is said to be consensus process. In this consensus process, okay, they may accept this particular transaction or they may reject the transaction. If they reject the transaction, that means the consensus is not achieved between the stakeholders or the verifiers. Okay, so this is what the thing to be followed by the verifiers. So in a public blockchain, we'll call this Krishna, Paras, and Radha are the miners. So these miners will verify whether the transaction is correct or not. If the transaction is correct, they will come to a conclusion that this particular transaction is correct or not, and they will make this particular transaction immutable and will enter into the ledger. So this is the way the blockchain will help us in achieving this particular verification. So what are the main things to be done by this Krishna, Paras, and Radha? Transaction verification. In this transaction verification, first of all, they need to verify identity of Ramu and identity of Gopal. If both are genuine, having genuine identity or not, need to be verified. Next is Ramu and Gopal's keys has to be verified. Keys has to be verified means, as we have just now, one of the participants asked, cryptocurrency. So here, we'll see this particular rupees 1000 is a digital currency, and this currency must be secured, and it should not be displayed out how much amount is going to be sent. So some confidentiality has to be maintained. So for that purpose, this particular transaction can be encrypted during the transit, so that at the receiving end, this encrypted data can be decrypted so that the original message may be achieved. So for this purpose, obviously, we all know that the public key cryptography algorithm is popularly used for this particular purpose whenever multiple entities involved and to achieve the greater security. So whenever the Ramu, Gopal, Krishna, and Paras, Radha, these people, business people, these entities involved in the business environment want to make some transactions, or anyone join the business network, first they will be supplied with the private key and public key. So Ramu will use the Gopal's public key and will encrypt this particular data, okay, encrypt this transaction, and will send to the Gopal. And now Gopal will use his private key and will decrypt this transaction, that is encrypted transaction, to get the original message. Now the task of Krishna and Paras and Radha is key verification. Identity verification means whether the Ramu is the same Ramu or not, and key verification is nothing but whether Ramu, what are the key used by Ramu is correct or not. Okay, that is whether Gopal's public key used by the Ramu is correct or not, and other related key key information need to be verified by these three entities. Then transaction validation. So this transaction need to be validated. So in order to validate this transaction, so first of all, signature verification will be done. signature verification is nothing but, it is not the handwritten signature, it is called as digital signature. So this digital signature will be used to for verification. So this signature will be done by the sender and will send to the Gopal. So the Gopal can decrypt it and can get the original message. So whenever the transaction is signed by the sender and this transaction is sent to the verifiers like Krishna, Paras and Radha, they may use the public key of the sender and can verify whether Ramu has really initiated this transaction or not. This is what they called a digital signature concept. The reason is, to have the digital signature, we need to use the public key cryptography. Symmetric key cryptography cannot be used for signature verification, signature creation or verification. Signature creation and verification can be done only via public key and cryptography only. So here this is called as digital signature. Now after that, once the verification is done and identity is verified and keys are verified, signature is verified, these three people come to an agreement whether the transaction is correct or not. So this is what we call reaching to a consensus. But what is the benefit for Krishna, Paras and Radha to verify this transaction? What they will get by doing this particular verification? So unless until there is no profit, they cannot do it. So if there is a profit or if there is some monetary benefit, obviously everyone will come forward. So to avoid this particular rush to verify, so there are some techniques used by the blockchain networks, which are called as consensus protocols, in which Bitcoin blockchain will make use of the proof of work as the consensus protocol, in which the verifiers or miners will be given a puzzle, so that the miners has to solve the puzzle and the result has to be submitted to the system. If the result is correct, that miner is eligible to add this particular transaction onto the ledger, and that particular solver or the miner who solved the puzzle will get some monetary benefits. This is what they called the process of proof of work consensus, which is mainly used in the Bitcoin blockchain. Next one is creating immutable ledger. In order to create the immutable ledger, cryptographic hash functions will be used, so that if any change occurred in the original message, the hash value will be disturbed. So using these cryptographic hash functions, the transaction will be hashed and the hash value will be recorded onto the ledger. In this way, the transactions will be recorded and a certain group of transactions will be added into or grouped and will be formed as a block, and the block will be added to the blockchain. That means a block consisting of set of transactions generated over a period of time. So how much period of time? It will vary from blockchain framework to blockchain framework. Like for example, in case of Bitcoin blockchain, the transactions a block will be created for every 10 minutes. That means the network blockchain network will wait for 10 minutes. In the 10 minutes, whatever the transactions generated, all those transactions, that is verified transactions, will be added into the block and the block will be created. And there exist some restrictions on the block also, that is how many transactions to be included in the block and what is the size of the block, etc. So far, Bitcoin will use the maximum 6 to 7 transactions to be enclosed in a block, and the block size should not exceed 1 MB. So this is the way how the entire system will work in the blockchain. Now the building block of blockchains, in which first of all one must have thorough understanding of transaction verification, that is identity, key verification. Next is transaction validation, how the digital signatures will be created. and how they are verified, and what are the different consensus protocols with respect to the public blockchains and private blockchains, and how to create this immutable ledgers. What are the popular cryptographic hash functions that can be used to create these immutable ledgers, and what are the other data structures like Merkle tree that will be used in the block creation also to be studied. So once you are thorough with these four things, then we can say that you are confident on the basic building blocks of the blockchain. Any doubts so far?
Sir, there is one doubt. How this immutable ledger is being created in the form of block? What is the main aim for this immutable ledger?
See, this particular transaction is a digital transaction. In future, anyone can tamper this transaction. Okay. So once the transaction is generated, in future, I may offline, I may go for like this. From rupees, I may change from rupees 1000 to 1500 or rupees 1000 to 500 itself. So that once the transaction is generated, once the transaction is modified something, then obviously it is a fraud kind of thing. So obviously, in such a cases, what we'll do is this particular transaction, this entire transaction will be sent on to a cryptographic hash function. For example, Ramu to Gopal, rupees 1000. I hope notepad is visible. Is the notepad visible?
Yes, sir. Yes.
Okay. Now what I
Yes,
will
sir.
do is, now in future there is a possibility that I may change it to 1500 because this is a digital. Somewhere it is recorded. It may be file or maybe database. Somewhere it was recorded. I may change it to 1500 in offline. So because there is no central authority. Because there is no central authority. If the central authority means bank will take care of and those people will take care. Central authority will. Since there is no central authority, anyone can access to this particular ledger, or sometimes the same person may change it in future. So that's the reason what I will do is I will send on to a cryptographic hash function. Okay, so that you will get a message digest. So this cryptographic hash function, this message digest. Now, whenever you got the message digest for the transaction 1, like that, you will get the message digest for the transaction 2, like any other transaction 2. Sometimes Krishna may initiate some transaction to Gopal, or Radha may initiate transaction to Krishna. Like so, like that, T3, T4, T5. So, like that, transactions will be generated. So, for every transaction, you will get one message digest, MD2, okay, MD3, MD4, MD5. Now, using this MD1, MD2, MD3, MD4, MD5, as just now I told you, that will add T6 also, MD6. So now 10 minutes are over according to Bitcoin. In Bitcoin, for every 10 minutes, one block will be created. Now this 6 transactions, okay, this 6 transactions will be formed in the form of Merkle
Block.
tree and added to the blockchain. Added to the block. Now MD1, MD2, MD1, MD2, MD3, MD4, MD5, okay, MD6. Now these are the independent hashes. Okay. Now MD1, just to combine the hashes of MD1, MD2, MD3, MD4, MD5, MD6. Okay, this is said to be message digest of all transactions. Clear? Now, in a block, you will be having message digest 1, that is first transaction MD, second transaction, third transaction, fourth transaction, fifth transaction, next transaction of all. Okay, all message digest of all transactions kept on hash function. Now you look at it. If anything was tampered, okay, if anything was tampered. So for example, from Ramu to Gopal, if I have made a change like this entire message registry will be disturbed. The reason is even a single change occurred. Okay, cryptography hash function. Okay. So here Ramu to Gopal rupees 1000. You look at here, this is the message digest generated. This is the SHA-256 hash function. This is the message digest generated. You look at, if you make a small change, look at, just to understand here, this is the message digest generated. That will, let I will place this here. Now, in future, if they try to modify it to 1500, you look at message digest change it. So it is invalid, right? Previously message digest what we have generated is different from this message digest.
Yes.
So thereby the transaction recording will become invalid and the block will become invalid. Because the reason is we have not only included this hash function, but also we have included the addition of, that is concatenation of all the transaction hash functions again sent on to the cryptographic hash function. So you will get the different hash function. This is the message address of all transactions. So if this was disturbed, automatically this will also be disturbed. Thereby subsequent dependents will also disturb. Thereby entire block will become invalid.
Invalid.
So this is what the way how this cryptographic hash function will be used for achieving the integrity of the transaction. I hope by this time you come to know the importance of the cryptographic hash function in achieving the immutable ledger. Immutable means which cannot be changed. If it is changed, if you are trying to change it, the block will become invalid. And in order to change it also, for any change, you must go through the public verification in case of public blockchains like Krishna, Paras and Radha. Obviously, they will reject the transaction because already this transaction has been recorded and it is not matching with the previous hash function, hash value. So thereby this will be rejected and the block may also be suspended. In case of Bitcoin blockchain, the hash function used is SHA, simple hash algorithm, SHA 256 bit. That means whatever the hash message digest generated is a 256 bit message digest. And remember, in Bitcoin blockchain, double hashing will be used. SHA 256 of this particular message. Okay. That means whatever the message digest you will get here, that message digest will be again sent on to the SHA 256 and you will get the final message. Clear? So that is the reason the cryptographic hashing in the Bitcoin is highly secured. This is highly secured because the reason is it is double hash, not single hash. It is double hash. thinking of 256 bit or decoding the 256 bit will take a very, very long time. Even though quantum computing come into the picture, it will take a long time. Still, with using quantum computing, if you are trying to decode it, but still because of this another hash, it is very difficult to get the original message. So anyhow, what are the cryptographic hash functions used are the one-way functions. That means only you will submit the message and you will get the digest. With the digest, you cannot get the original message. It is very, very difficult to get the original message with the help of the cryptographic message digest. So even though you try to do this, still you will fail. The reason is the Bitcoin blockchain will use the double hashing of SHA-256. So I will move forward. So let us consider the problem. So this is the problem. Since each and every one is maintaining their own ledger, so keeping track of the entries in the ledger is very difficult. So separate keeping ledger is inefficient, expensive, and vulnerable. So that is the reason we are going for the blockchain, which is a trusted distributed ledger, which is shared across the business processes. It allows a shared replicated permission ledger with a consensus, provenance, immutability, and finality. Consensus you are aware of. Provenance means it is the chain of ownership. Okay, keeping track of the chain of ownership. For example, in case of land registrations. So land registrations, whenever you purchase any flat or building, so obviously there will be a chain documents. Chain documents means originally that is how the government has made the layout, to whom first it was sold, and the first person sold to whom. So like that, the chain of documents will be there. So in the first time who purchased that plot or flat, so obviously will become the first person. That is the first owner, then the second owner, third owner, like that. So this kind of chain of ownership will be recorded in the blockchain also, which is called as provenance. And immutability. Immutability means, as now just now we have seen that cryptography that is the cryptographic hash function, where you go for the cryptographic generation of message digest, and thereby you will achieve the immutability. Finality means once you have recorded onto the blockchain and the blockchain block is committed, then you cannot roll it back. Called finality. So one single ledger will be distributed among all the participants in the business network. So this is what thing called blockchain is. So a block is a historical record of transactions, much like a database. So blocks in the blockchain is just like nodes in the single linked list. So you know that in a single linked list, first there is a head node, and the head node to the head node you will add the next node and keep on adding the nodes. So in case of single linked list, so the nodes will be added anywhere at the beginning, middle, or end. But in case of blockchain, the blocks will be added only at the end of the chain. The reason is the first block that is going to be created is said to be the genesis block, and this entire block consisting of some hash value. This hash value will be used in the next block, and the entire block will be hashed. So like this particular block, this block 1, say for example, block 1 is having the message digest of the 6 transactions and a combination of all the 6 transactions. Okay, and also along with this combination of all 6 transactions, I will also add hash of block 0. So I will also add hash of block 0. So thereby what will happen, if block 0, if there is a problem or if there is tampering in the block 0, obviously it is the block 1 is depending upon the block 0. So block 1 transaction or block 1 hash will also be get destroyed. So this is the way, this is the reason if you disturb one transaction or one transaction in a block, automatically all the subsequent blocks will be get disturbed. In case of single linked list, just like how the next node will store the address of the previous node, so like that, the next node in the block will store the address, hash value of the previous block. So thereby all the subsequent blocks will be depending upon the previous blocks. If any change was occurred in the previous blocks, obviously subsequent blocks will be get disturbed. So in case of blockchain, the block will be added only to the end of the blockchain. You cannot insert the blockchain in the middle. The reason is, if you try to add the block here in this particular place, obviously this block has to take take the value of previous block hash, and the rest of the process has to be performed. But if it is so, then automatically the rest of the blocks will be get disturbed. So that is the reason the in the blocks can be added only to the end of the blockchain. In the blockchain, each block has a header consisting of the information such as data about the block, technical information, a reference to the previous block, digital fingerprint, also called as hash of the data contained in the block, among others. This hash is important for ordering and the block validation. And the content of the block, example, information about the transaction. Let we'll see, this is the Genesis block. So what is the first block in the blockchain is said to be? It is said to be the Genesis block. So this is the block 0 of the Bitcoin. Here you look at, this can be found here. Then the Genesis block, this is the URL link. You can also see this particular URL link. This is the block 0 of the Bitcoin. You look at, this is the hash of the first block, and this is the timestamp when it was created, 2009, 1st March. Okay, this is the block height is 0. That is the first block. Miner unknown. You don't know who is the miner. Number of transactions, only one transaction. Difficulty is 1. What is the difficulty means? The mining difficulty. That we'll see afterwards. Merkle root. This is the root of the Merkle tree. And version. This is the version. Bits. And here, this is the transaction. What is the transaction fee here? 50 BTC. So first block was created with the 50 BTC. Then the next blocks were created subsequently. So the building blocks of blockchain, first one must know networking, cryptography, data structure, and consensus. So if you can come to know these 4, then you will be knowing the blockchain building blocks. So we all know that the blockchain is a decentralized and a distributed network. The nodes in the blockchain will communicate in a peer-to-peer fashion. In cryptography, the encryption, decryption, hashing, and digital signature concepts must be aware of. Then in the data structure, single linked list, that is linked list concept, Merkle tree, distributed ledger technology, and the concept of databases. In case of consensus, proof of work, proof of stake, proof of elapsed time, Paxos, practical Byzantine fault tolerance, and draft. So I hope much introduction is not required for the networking. So blockchain is a decentralized distributed network pattern, and nodes communicate them among via peer-to-peer fashion. So in the peer-to-peer architecture, BitTorrent is one example, and IPFS is another example. So here public key cryptography will be used. So we all know that in conventional public key cryptographies, like the RSA algorithm and all, and here especially in the Bitcoin, it will use the elliptic curve cryptography as a public key cryptography, and it will use the SHA-256 as the cryptographic hash function, and use the elliptic curve digital signature algorithm as the digital signature algorithm. Consensus algorithms are proof of work, need to solve a cryptographic hash puzzle to add a block. And how to use this particular cryptographic hash puzzle? Like for example, listen carefully here. As we have seen, there are verifiers. Ram, Radha, and Paras, and as I shown in the slide. So these are the verifiers, and these verifiers will get a puzzle. How this particular puzzle will get? So let, for example, already block 0 was created, and we know the hash of block 0. We know the hash of block 0. Already we know the hash of the block. Now, what the blockchain framework will do is hash of block 0 plus it will concatenate some very large random number, okay, and will perform hash of this. So thereby you will get a message digest. Now, just to listen carefully, we know the hash of B0 because everyone know, because block 0 is already created. Okay, assume that block 0 is already created. Everyone know the block 0 hash value also. So this block 0 hash value plus a very large number will be taken by the system itself, that is the blockchain framework itself. You don't know what is the large number, and thereby one message digest you will get. Now the blockchain framework will give you the previous hash value and the message digest. As a verifier, okay, as a verifier, you verify that this is correct, this transaction is correct. Now you want to commit this transaction into a block. Now the Krishna, Radha and Paras, as the miners, they have to solve this puzzle, that they need to verify what is this very large random number. This random number will be drawn from a large number of. You don't know what is that number. So searching this number is a very difficult task. The reason is, if I have dropped a small pin in a small 10 by 10 room and ask you to find out, so obviously it will take 1 or 2 minutes to identify where it is. In the same way, the same pin I have thrown into a big hall of 50 by 50. Then obviously it will take some time. It's not difficult, but takes some time. Okay. The same pin, if I have dropped into a university campus and asked you to identify, okay, or a basketball court to identify, okay, so it's somewhat difficult, but still you can find. But in a university campus, like big campus, it's very, very difficult to identify where the pin is. In the same way, if you might have taken a random number between 1 and 1000, okay, it's fine, you can easily identify. 1 lakh is also okay, 1 crore is also okay, 10 crores also okay, but it was taken from very large pool of numbers. Then it is a very, very difficult task for you to identify it. So that is the reason you require specialized hardware to identify what is that particular random number. Okay. So this particular hash puzzle difficulty will vary for every 2 weeks in case of Bitcoin. So the current difficulty is equal to previous difficulty into milliseconds in 2 weeks by milliseconds to mine last 2016 blocks. So because why 2016 blocks? We know that block in Bitcoin will be created for every 10 minutes. So thereby, for every 2 weeks, 2016 blocks roughly will be created. Okay, so this is what the general idea of this particular formula. So the difficulty of this puzzle will increase based upon this particular formula in the Bitcoin. And this is the hash rate versus difficulty, how many hashings are required for achieving this difficulty. Because the cryptographic hash function used here is the SHA-256. So obviously, there are how many possible message registers you will get. So 0xXFF into 2 power 208, and this is the difficulty level, and Okay, and this many number of transactions, this many number of hashes need to be calculated for every second. So thereby, normal computers is very difficult to go through this. So that is the reason you require some special hardware for this. It's called as application specific integrated circuits. Here, this is a one setup example, a setup for the mining station. Actually, this particular level is also now crossed out. Now we require a huge mining station for mining these particular bitcoins. Majorly, these mining stations nowadays, I come to know that it is around in the nearby Ukraine and these places. So that is the reason, because of the Ukraine and Russia war, nowadays this particular Bitcoin is also coming down. The rate is also coming down. So that is the reason one cannot afford this particular hardware. Obviously, mining pools were developed, and this is the mining pool. Mining pool means here it's just like it's a collaborative work to solve the mining puzzles. So finally, we'll see the blockchain versions. Blockchain 1.0, which is totally deals with the distributed ledger technology. Only distributed ledger technology will be available, which is called Bitcoin. Example is Bitcoin for this. And blockchain 2.0, blockchain 1.0 plus smart contracts. So smart contracts, that is, we know that business contracts will be, a contract is said to be happening of a transaction on condition. So here smart contract means automatically this condition will be executed and the transaction will be performed. Like for example, there is a minor. Minor means here in case of age in India, which is the person who is less than 18 years of age is said to be minor, and 18 plus is said to be major. For example, a minor is there, minor girl or boy is there. On his name, on his or her name, there is a property under a guardian. Now in the registration process or in the property registrations, you might have join a blockchain which is maintained by the government, for example, and there is assume that this is the contractor. If the minor, a child, achieves the 18 years of age, the property has to be transferred from minor's name to the from the guardian name to the minor name. Okay, the person name. So that means the contract will keep track of the condition, the age of the person. If the age of the person is greater than 18, automatically some transaction, the transaction will be initiated to shift the name from the guardian or custodian name to the person's name, that is child name. So this is the way how the smart contract will be executed. For this, you will write the conditions. For this, you will use a language. In case of Ethereum, we use this Solidity as a smart language for this. So blockchain 1.0 plus smart contracts. Smart contracts are the small programs that live in the blockchain. So example is Ethereum. Next, blockchain version 3.0, blockchain 2.0, that is all the features which are there in the blockchain 2.0, plus decentralized applications, that is front-end applications plus smart contracts. Blockchain 4.0, blockchain 3.0 plus industrial applications, like usage of IoT or blockchain for industry applications such as automation, ERP, etc. So this is called, example is blockchain for supply chain management, where RFID devices, IoT devices, many other things will come into the picture to make an enterprise resource planning and industrial application. So these are the various versions today, and in which we are going to see the Ethereum programming, Ethereum smart contract programming Solidity, and also the decentralized applications development on the 4th day. So this particular hash puzzle difficulty will vary for every 2 weeks in case of Bitcoin. So the current difficulty is equal to previous difficulty into milliseconds in 2 weeks by milliseconds to mine last 2016 blocks. So because why 2016 blocks? We know that block in Bitcoin will be created for every 10 minutes. So thereby, for every 2 weeks, 2016 blocks roughly will be created. Okay, so this is what the general idea of this particular formula. So the difficulty of this puzzle will increase based upon this particular formula in the Bitcoin. And this is the hash rate versus difficulty, how how many hash strings are required for achieving this difficulty, because the cryptographic hash function used here is the SHA-256. So uh, there are how many possible message registers you will get. So 0xx into 2 power 208, and this is the difficulty level, and okay, and this many number of transactions, this many number of hashes need to be calculated for every second. So thereby, normal computers is very difficult to go through this. So that is the reason you require some special hardware for this. It is called as application specific integrated circuits. Here, this is a one setup example, a setup for the mining station. Actually, this particular level is also now crossed out. Now we require a huge mining station for mining these particular bitcoins. Majorly, these mining stations nowadays, I come to know that it is around in the nearby Ukraine and these places. So that is the reason, because of the Ukraine and Russia war, nowadays this particular Bitcoin is also coming down. The rate is also coming down. So that is the reason one cannot afford this particular hardware. Obviously, mining pools were developed, and this is the mining pool. Mining pool means here it's just like it's a collaborative work to solve the mining puzzles. So finally, we'll see the blockchain versions. Blockchain 1.0, which is totally deals with the distributed ledger technology. Only distributed ledger technology will be available, which is called Bitcoin. Example is Bitcoin for this. And blockchain 2.0, blockchain 1.0 plus smart contracts. So smart contracts, that is, we know that business contracts will be, a contract is said to be happening of a transaction on condition. So here smart contract means automatically this condition will be executed and the transaction will be performed. Like for example, there is a miner. Miner means here in case of age in India, which is the person who is less than 18 years of age is said to be minor, and 18 plus is said to be major. For example, a minor is there, minor girl or boy is there. On his name, on his or her name, there is a property under a guardian. Now in the registration process or in the property registrations, you might have join a blockchain which is maintained by the government, for example, and there is assume that this is the contractor. If the minor, a child, achieves the 18 years of age, the property has to be transferred from minor's name to the from the guardian name to the minor name. Okay, the person name. So that means the contract will keep track of the condition, the age of the person. If the age of the person is greater than 18, automatically some transaction, the transaction will be initiated to shift the name from the guardian or custodian name to the person's name, that is child name. So this is the way how the smart contract will be executed. For this, you will write the conditions. For this, you will use a language. In case of Ethereum, we use this Solidity as a smart language for this. So blockchain 1.0 plus smart contracts. Smart contracts are the small programs that live in the blockchain. So example is Ethereum. Next, blockchain version 3.0, blockchain 2.0, that is all the features which are there in the blockchain 2.0, plus decentralized applications, that is front-end applications plus smart contracts. Blockchain 4.0, blockchain 3.0 plus industrial applications, like usage of IoT or blockchain for industry applications such as automation, ERP, etc. So this is called, example is blockchain for supply chain management, where RFID devices, IoT devices, many other things will come into the picture to make an enterprise resource planning and industrial application. So these are the various versions today, and in which we are going to see the Ethereum programming, Ethereum smart contract programming Solidity, and also the decentralized applications development on the 4th day. So here the taxonomy of blockchain systems. Public blockchain, it is open to the world, attracts many users, and communities are very active in this, like Bitcoin. So in this, there is no permission required. Anyone can join this network. While coming to the private blockchain, permissionless blockchains, it is for small communities. Many companies are developing frameworks for its efficiency and ability. IBM Hyperledger is one kind of permissioned blockchain. In the public blockchain, you will find complex consensus algorithms. In private blockchain, consensus algorithms are very simple because it is managed in a small group. Only 1 or 2 people will be having the authority to commit the transactions. Consortium blockchain is a group of business people will form as a consortium and will start their applications, blockchain applications, which is said to be consortium blockchain. If you are going for only cryptocurrency support, then go for the Bitcoin. That is, you may inspire from the Bitcoin. Currency support plus smart contracts, Ethereum is the best suitable platform. Then only smart contracts, Hyperledger Foundation. That is Linux Hyperledger Foundation. In this, there is no use of the cryptocurrency or currency support in this particular Linux Foundation Hyperledger. So that is the reason we are going to cover the Ethereum and Solidity programming in this episode. So quickly, I will go through this particular flow chart because next speaker is waiting. So start the project. If you want to, what type of blockchain need to be considered for the project that you are going to develop? So first of all, decide whether can you rely on the trusted third party or not. If you can't rely on the trusted third party, then move on to the next stage. Okay, check for the next condition. If you can rely on the trusted third party, that means I can rely on the bank. So no need of blockchain here. So I can simply trust the bank and go for the transaction. So I cannot rely on the third party. So then go for the next checking. Is database to be stored or database needed? If database needed, okay. If database is not needed, then blockchain is not required for your project. If the database is required, then check for whether the multiple writers exist. If there are no multiple writers, then the blockchain is not required. Then if multiple writers are not exist, okay, multiple writers exist, then writers are unknown, untrusted, and have conflict of interest. If there is no conflict of interest, okay, then blockchain is not required. Okay. Otherwise, you move on to the control access control. Whether any access control is required, because a person has to view only this much information, and another person may view that much information. Some access control need to be maintained. If there is no access control, if the access control is required, then the transactions to be made public. If the transaction to be made public, then you don't want to look for the immutability versus efficiency trade-off. Then you go for choosing of the public blockchain. Access control required, no. Are transactions public? No. And immutability versus efficiency trade-off, no. Then go for checking of is multi-party consensus required? Okay. If it is yes, then consortium blockchain. Otherwise, go for private blockchain. So this is what the flow graph with which you can decide for your project whether the blockchain is required or not. So with this, I stop my presentation. If you have any doubt, you may ask. Then we can move on to the next session.
If you have any questions, please ask. Audience. I think there are no questions. Thank you, sir.
Okay, thank you. Thank you, all the participants.
Thank you for your enlightening and entertaining talk. It is worthy to say that you explained so nicely through Ramu and Gopal example. Thank you once again for sharing your knowledge. And our second, yes, surely we will share the PPT. Once the FDP will be over, then we will share.